Hello, and welcome back to the OceanBase YouTube channel. I'm Annie from OceanBase Community. Today we're diving into a key topic in modern data, retrieval, text embedding and retrieval. If you've ever wanted to search through vast amounts of text and find exactly what you need, then this video is for you. We'll explore how text embedding works, how it's used for retrieval, and how OceanBase vector database can make it all faster and more efficient. Let's start with the basics. What is text embedding? Text embedding is the process of converting text, whether it's a word, sentence, or entire document, into a fixed-length vector of numbers. These vectors capture the semantic meaning of the text, so instead of comparing raw words or phrases, we compare the meanings represented by these vectors. For example, if we take the sentences, "the cat is on the mat" and "the dog is on the mat," even though the words are different, the embeddings for these two sentences will be close to each other in vector space because they share similar meanings. So, how are these embeddings created? Text embeddings are typically generated using machine learning models like BERT, GPT, or Word2Vec. These models are trained on large datasets to learn the relationships between words and phrases, and they map the text to a vector space. For example, BERT uses a deep learning architecture that looks at the context of words in a sentence. By analyzing how words relate to one another, BERT generates embeddings that capture the meaning behind the text. The more context the model can analyze, the more accurate the embeddings will be. Once we have text embeddings, we can use them for text retrieval. Text retrieval is all about finding the most relevant pieces of text based on a query. With traditional search engines, you might search for keywords, and the engine looks for exact matches. But with text embeddings, we're looking for meaning, not just words. This is where things get interesting. Imagine you're searching for how to train a machine learning model. With text embeddings, a search engine can return documents that are semantically similar to that query, even if the exact words don't appear in the text. This makes it possible to find relevant information more accurately and quickly. So, how does OceanBase fit into this? Well, with OceanBase vector database, you can store and retrieve text embeddings at scale. OceanBase allows you to efficiently query millions of vectors to find the most relevant pieces of text, no matter how large your dataset is. This is especially useful when you're dealing with large collections of documents, customer support tickets, or even user-generated content. OceanBase vector search capability lets you do this with high speed and accuracy without needing to rely on traditional keyword-based search. Now, let's look at some real-world use cases for text embedding and retrieval. One of the most common is document search. With text embeddings, you can implement a system where users can search for relevant documents even if they don't use the exact words or phrases that appear in the text. Another use case is customer support. Imagine a user submits a support ticket asking about an issue with a product. A text embedding-based retrieval system could quickly find past tickets or knowledge base articles with similar problems, giving support agents the information they need right away. To wrap up, text embedding and retrieval are transforming the way we search and interact with text. By converting text into meaningful vectors, we can create smarter, more accurate search systems that go beyond simple keyword matching. And with OceanBase vector database, you can take advantage of this technology to build high-performance applications that retrieve the information you need faster and more efficiently. That's all for today's video. If you found this helpful, make sure to like, subscribe, and hit the notification bell so you don't miss our next video. Thanks for watching, and see you next time.